Jupiter is huge, but some planets make it look tiny. So how large can a planet actually become? Is a world this size still a planet, or is it something else entirely? To understand the scale, we start with the king of our own neighborhood. Jupiter is the largest planet in our solar system. It's about 11 times wider than Earth and has roughly 318 times its mass. But beyond our sun, telescopes are revealing worlds that push the boundaries of what we thought was possible. These are the super Jupiters, giant gas planets that contain substantially more mass than our own. Some of these exoplanets are several times heavier than anything in our own system. You might think that adding more mass would simply make a planet bigger, but the physics of giant planets don't follow that simple logic. In fact, adding weight can have the opposite effect on a planet's physical size. Here is the surprising part. Giant planets don't just grow wider as they gain mass. This is due to a process called gravitational compression. As a gas giant gains mass, its inward gravitational pull becomes much stronger. That gravity squeezes the planet's interior. A planet several times more massive than Jupiter may be only slightly larger in radius, or even similar in size, because it is becoming denser rather than physically larger. Consequently, a planet's weight and its physical dimensions are separate measurements. In the realm of giants, more mass does not equal a much bigger world. These worlds begin in a protoplanetary disk. In a model called core accretion, dust and solid material collide to build a massive core. Once that core is heavy enough, it attracts massive amounts of surrounding hydrogen and helium gas, ballooning into a gas giant. Another model, called gravitational instability, suggests parts of the gas disk might collapse directly into these massive objects. Both models explain how planets grow so heavy, but as they accumulate mass, they approach a structural threshold where they begin to resemble stars more than planets. When a gas giant becomes massive enough, we reach a classification question. Is it still a planet, or is it a brown dwarf? Brown dwarfs are often called failed stars. They are more massive than typical planets, but too small to sustain the regular hydrogen fusion of a star. A common reference point for this transition is about 13 Jupiter masses, but this isn't a universal rule. Because scientists also consider how an object formed, the boundary between the heaviest planets and the lightest brown dwarfs remains a subject of ongoing research. Because exoplanet measurements have uncertainties and classifications vary, there is no single, universally accepted record holder for the largest planet. Jupiter remains the king of our solar system, but the wider universe is filled with giants that defy simple labels. The question isn't just about how wide a planet can grow. It's about the exact point where a planet becomes something else entirely. For more fascinating science, space, technology, and the complex facts of our universe, follow Fusion IQ. Like, share, and subscribe for more.